Good morning, everyone. My name is Jeff Cole, and I'm the BMC host for the monthly AMIOPS Coffee Talk sessions. As we do with all of the Coffee Talk sessions, questions will be taken via chat, or if you prefer, you can send them to me directly via email at jcole@bmc.com. In this Coffee Talk session, AMIOPS software consultant Tom Nurse will discuss the value of BMC health checks. So without further ado, Mr. Nurse, the floor is yours.
Okay, thank you, Jeff. Good morning, everyone, and welcome again to the Coffee Talk series. As Jeff mentioned, my name is Tom Nurse, and I'm a Senior Technical Software Consultant at BMC Software. The subject today, unlocking AMIOPS value with BMC health checks. So grab a cup of coffee or your favorite beverage. Me, I go for maximum sugar this time of day. But regardless, let's get started. In today's session, we'll cover what a health check is, what are the benefits of a health check, how does the health check process work from the customer's perspective, and we'll go through some use cases, some sample health check deliverables. Before we go further, though, let's clear up some terms. As many of you know, BMC rebranded its Z monitoring products from MainView to AMIOPS in early 2021. So MainView for DB2 became AMIOPS for DB2, for instance. And MainView for SRM is now AMIOPS for storage. Same products in essence, but with the additional benefit of AMIOPS. That is a new interface, more API, ever more AI and machine learning capabilities. So if you own MainView products, you'll notice that when you upgrade to the latest release, these monitoring products will now be called AMIOPS. And I'll occasionally use the older term MainView during this presentation. Now, MERT was the name of the automated process we used to gather and analyze MainView data for health checks. It's now called AIR. Again, same process in essence, just renamed to reflect the move from MainView to AMIOPS. And finally, the term assessment is really synonymous with health check. You'll hear both terms used interchangeably. I'll use health check for this presentation. So you may have had an SE or a TAM talk to you last year about doing a MainView assessment using MERT. Today, he or she would say an AMIOPS health check using AIR. Essentially the same thing. So what is a health check? Okay, there's a lot of words here, but I like this definition. It's a process in which a BMC software consultant or technical account manager works with folks in operations monitoring to gather and analyze MainView AMIOPS configuration information to look for anomalies, to find ways to make improvements and a path to increased efficiency, to ensure that AMIOPS products are meeting your monitoring goals and overall mainframe and IT initiatives. So a health check may begin with an interview, just to clarify customer goals, issues they might be having, things like that. But the heart of the health check is AIR. And this is a tool used by BMC that goes deep into the customer's implementation. It gives us insight as to how you're using AMIOPS and recommendations of how to use it better. And it removes the onus from the customer of trying to come up with all the details of configuration. The health check concludes with a formal presentation with supporting documentation and those recommendations. And every MainView AMIOPS customer is entitled to a health check, even multiple health checks on a regular basis. And these are free. The SEs and TAMs, it's our way of ensuring that customers are getting the most out of their monitoring products. And this is just a great way to make that happen. So what is AIR? First, a quick shout out to those BMCers who took an idea and made it a reality. There's one SE, one TAM, and one person in development. That's Mark, Gilles, and Ken. Well done. Thank you. AIR, which stands for AMIOPS Inventory Reporting, is indeed a reporting tool. It is run at BMC against the data the customer sends it. So the customer doesn't have to worry about how this tool works or installing it or anything like that. It runs at our place. And it uses the Explorer to extract AMIOPS configuration data and put it into a number of CSV files that are sent to BMC for analysis. And what error produces are a set of reports which give details about the total AMIOPS implementation. These reports are used in the health check to offer recommendations of how to correct or enhance the customer's AMIOPS monitoring. So here's the dashboard of AIR itself. Now on the left are the AMIOPS products. We can break out, what alarms are being used, threshold levels, monitors, automation. Each of these buttons represents a report. A number of these reports will be used as supporting documentation in the health check. So let's click here. To get an example of one of the high-level reports, this tells us the number of targets per product per system. So the column on the left is the system name, and it's not your eyes. I've blurred those out. And you can see at the bottom of this first column, there are a total of 12 of these systems. The next column is the total number of targets. That is the number of AMIOPS targets being monitored on that LPAR. The rest of the columns are potential AMIOPS products. Looking across this matrix, I can see that AMIOPS for ZOS is running. We've got SysProg, CMF. Now for the Explorer, I see they've got it running on 3 systems, and that's all right. That's all you really need because of AMIOPS' ability to con to multiple systems. I see auto operators running everywhere except for one system. And I can see that they have AMIOPS for kicks and how many targets they're running on every system. So I can quickly say that this system right here has 148 kicks regions running on it. In fact, let me make my highlighter here. So yeah, right here, there's 148. And for all 12 systems, there's 455 kicks regions for a total of 597 targets across all AMIOPS products. So let's look at why a health check is important to you. Here we have the customer represented on the left and BMC on the right. So getting up-to-date information can be a challenge. We can ask, hey, what hardware have you got on the floor? What is your monitoring configuration at this moment? A DBA might say, hey, we've got 40 DB2s, but a kicks guy says, no, we only have 35. And that's normal. It happens everywhere. It happens in our data center too. But AMIOPS, and again, what used to be known as MainView, has all this data inside. So what a health check does is it helps enhance understanding on both sides. We strive to understand the customer's hardware setup and their AMIOPS configuration down to every last alarm. And once we understand this environment, we can make recommendations for improvement. And the customer needs to be aware of all the latest capabilities and features that we offer, especially those that can help meet their monitoring goals. So we're going to use the data from AMIOPS reporting to understand the customer's environment, regardless if they have one LPAR or multiple KECs. And we will gather hardware and software data. We can detect model and LPAR information, coupling facilities, what software releases they're running, what DB2 releases are running on each LPAR, what's the ZOS level, what releases of the various AMIOPS products. We can show you the alarms that are running, what monitors, the automation. We can make sure that actions are taken when thresholds are breached. Otherwise, what's the point of that particular alarm or monitor? And how to monitor more on your applications. The benefits to the customer? Well, you can avoid older versions or known errors. Identify knowledge gaps. Are best practices being followed? Maybe some training is in order, especially to highlight new functionality that can help the customer. Now, this is a big one. We're going to tie all the alarms and monitors to automated actions. Make sure that the customer's use of AMIOPS works with their monitoring goals and future initiatives. So here's a bunch of questions. These key questions can be answered in the health check, or you can ask them in another way. You can say, How has your main view infrastructure been implemented? What alarms have been defined? What's their status? Which kicks DB2 and IMS monitors are active? What about auto operator? What about the rules and execs? Are they firing? So let's look at how this process works. Okay, here's the process flow. 1, the customer collects AMIOPS data using the Explorer and preset configurations, then sends CSV files to BMC. 2, we load them into AIR, these CSV files. And then 3, we run the reports, we do the analysis, we create a presentation, then go through the health check with the customer. Almost all of the time spent is on step 2, the analysis phase. So for the customer, it's just really a few minutes for step 1, and then at the end, however long it takes for the formal health check presentation. Maybe it's an hour, maybe it's a couple hours. So let's focus specifically on step 1 to see what the customer needs to do to kick off this AIR process. Okay, specific steps to collect the data for AIR analysis. So your BMC SE, like me, or a TAM, will send you configurations to be used only to generate data for AIR. So you're going to use these just for a moment. All right, you're going to load them into your BBC def on the mainframe, and then open each of these configurations in the Explorer. And the number of configurations will depend on the number of AMIOPS or MainView products that you have. You're going to validate a correct ConDef to be used to capture as many LPARs as possible. This will probably be a con all. Okay, then you're going to set the AMIOPS Explorer export location. This is where the CSV files will be sent on your Windows machine. And then you're going to send those CSV files back to BMC. So the amount of time this will take you is maybe around a half an hour. And this includes all systems that you've conned to, as well as multiple AMIOPS products. Now, note, there's an asterisk. There's always an asterisk. There are a couple of exceptions, console management and AMIOPS for storage, which use a different architecture and have no alarms, respectively. So console management actually takes less time. Literally, click a button on the admin page, it downloads a file, you send that file to BMC. SRM, on the other hand, takes more time. And we're working with this product to make it as streamlined as the others. So here's a list of prereqs needed to use AIR effectively. If you're currently running AMIOPS, that's our latest release, you're good, okay? And these are the minimum levels for the infrastructure along with a few of the more common AMIOPS products. Of course, any questions with any of that, just call us and we'll be happy to walk you through it. So let's look at a few use cases. A health check usually involves multiple AMIOPS products, but we often divide the products into separate deliverables. So here, we'll look at the AMIOPS for DBT portion of this health check. Okay. We use this slide as the kickoff to the health check. Our audience is usually, first line manager and the technicians. And these are the objectives and deliverables. So under objectives, we have validate how key MainView for DB2 or AMIOPS for DB2 features are being leveraged, identify new requirements, and help prioritize or document next steps. Okay, that leads us to the deliverables. We're going to have a summary of how AMIOPS for DB2 is being utilized, an extensive summary. And then we're going to have those recommendations to help, drive additional benefits from the solution. And listed along the bottom line there are some core tenets that are shared by many of our customers. So let's get started. So this chart was produced by AIR, and this view is a high-level inventory of the customer's environment. The customer did a con all, and the result is a snapshot of the configuration coming from all those systems. So we have a quick way to look at their complete environment, in this case, production. And it's a total of 72 systems. Now, they have a test environment of something like 118 LPARs, but they wanted to just focus on production for now. So that's what this health check entails. So if you look along the bottom of the columns on the last page, you see we have 709 subsystems, 333 kicks, 78 DB2s. We're going to focus on those 78 DB2s. So this is typically the first main slide we use in the health check, and it works as sort of an executive summary. It lays out the features on the left and the potential benefits of those features. That's in the middle. And on the right are findings. So this is still at a high level. The next couple slides will go deeper. So, if you look at an example, we can take for a feature proactive monitoring. Potential benefit is alarm management using persistence checking and background monitors. And the findings were, hey, there's good usage of alarms and automation rules. So again, features of the product, how they benefit you, and then how the customer is doing. And you'll see these green dots over here. Green is good. It indicates that the customer is doing something meaningful in this area. Yellow doesn't mean bad. It just means we probably need to look into it a little further. Right now I'm seeing nothing but green, and that's good. So this is where we start digging into the data a little bit more. Okay. According to our AIR analysis, the customer has 36 metrics monitored with alarms and 1,292 alarms deployed across 78 subsystems. Okay, so how do we get these numbers? This is supporting documentation that you would be sent, and we used AIR to look at a particular report called DB2 Alarm Metrics Monitored. We can see on the left the names of these alarms, and on the right, the number of times those particular alarms are used. From this report, I know that the very first metric, let's call it ABLE, there were 4 alarms deployed. The next one, there were 10, and so on as we move down the list. So if we go to the end of this list, we see 36 unique metrics, and they're deployed 1,292 times. That's what they've deployed to monitor their 78 DB2s. So these are pretty good-sized numbers. They've done a lot of work here. Let's go back to the current state slide. And next, they want to know how many best practices metrics are being used today. The answer, 20%. Now, is that a low number? It depends. On the face of it, it seems pretty low. Our best practices metrics have been developed over decades of working with customers. They're widely used. So how did we come up with the 20% number that they're using? We're going to drill down a bit, again, into AIR, and this is best practice metrics used by Alarms report. So across the top of this report, we have metric name, view, metric description, why it's best practice, total alarms defined, and view used. So if you look at the bottom of column 1, it looks like there are 17 metrics here, but actually it's 10. Why? Because UTCB time was broken out by view use. It's used by 8 different ones. Therefore, we just have 10 unique best practice metrics here, and only UTCB time and one other one are being used. So that's 2 out of 20, or 20%. A seemingly low number. So this will be discussion point with the customer. This is something we'll bring up with them. And, there might be a good explanation. Maybe they really don't need that 80% of best practices they're not using. Or maybe they have their own metrics which are similar to best practices. This is stuff we just bring out, and it's up to the customer to decide ultimately what they want to do, if anything. Let's go back to the current state, and we see 125 unique alarm definitions, 1,292 alarms deployed across 78 subsystems for an average of 16 alarms per DB2 subsystem. And again, we find this information in an AIR report. We see the names of 125 unique alarms spread across these systems. 1,300 total alarms are running, which is a lot. So you do the math, and there are an average 16 alarms per DB2 subsystem. So you can see there's a lot of activity going on here. Let's go back. Now we're going to move from alarms to monitors. And we've got 156 unique DB2 monitors. Around 3,000 were deployed to monitor the 78 subsystems. So you really consider this. You got 3,000 monitors and 1,300 alarms for a total of 4,300 that are running just to manage their different DB2s. That's impressive, especially in light of the fact they have maybe just one or two DB2 people who are managing all of this. And again, this is just production. This does not include test dev. And again, here's our report out of AIR, which we use to derive those numbers. We show all the same type of information. We break it down by PARMs. If there was a server and a unique PARM, we counted it. So you can now see the number of servers across all of their systems is 156 and a total of 2988. And 2988 divided by their number of subsystems is 38. So it's about 38 monitors per DB2. It's quite a few. We want to mention we'll also have best practices for monitors as well as alarms. That's coming down the pike. So let's get into automation. The automation, this was the big thing they wanted. What are they doing when an alarm or monitor fires? Okay, so they got 903 alarm rules. 91% of them called an exec. And they wanted to know, among other things, how many email execs are they doing? Because they had many that did nothing but notify the team that there was a situation. So which ones are using email execs? Turns out it's 39%. So here we've broken out all the different execs for our alarm definitions. In this particular case, we happen to know that the email execs have a certain prefix. So we simply added together those types of execs and to come up with these totals. So the sum of these numbers, and they're right here, the sum of these numbers divided by the total number of alarms tells us that 39% of execs are doing nothing but emails. So in this case, we would direct the customer to a new feature that gives the ability to call email in a rule. In this way, they could eliminate a large number of execs, which would be something they would have to otherwise maintain. So this is a good example of what is brought up when we get to the recommendations phase of the health check. So what automation is supporting all of these monitors we just saw? 156 unique DB2 monitors. We have 1,540 rules. So how many of these rules are calling execs? All of them. And that was their goal. They did not want a monitor or an alarm running that didn't do anything because it's useless. They wanted some type of action to always be taken. So in this case, the health check just confirmed what they set out to do. And overall, this is really a very solid implementation. So what automation is supporting all of these monitors we just saw? And here, okay, so here is the supporting AIR report for that, and I want to be cognizant of my time. I'm just going to move on to the very last thing. And this question is, how many of these monitor rules are calling email execs, okay? So we saw the alarms, these are the monitors, and the answer is 47%. And just like before, we could improve this situation by showing them how to call email directly from a rule. So we talked previously about current states and benefits. You know, we've got the historical data usage out of the box, which we touched on with best practices, and the user interface. So we have the current state and the benefits derived. Now here's our recommendations. So they've done a lot, but they want to get simpler. They want an action for everything. They want to remove some execs. We can show them a way to do that. You know, the clutter of those email execs, for instance. Out of the box, we definitely want to review what seems like a low usage of best practices. We just want to talk to them about that, make sure that they've got everything covered. And the interface, we're recommending the new UI. It's HTML5. It does a lot, and we think they'd get a lot of benefit out of it. So here's the final kind of slide for the DB2 portion of the health check. And we work with the customer to determine the priority. So you've got review alarm definitions across the production systems, review the monitor definitions, implement rule management and standardized definitions, and review DB2 best practices metrics. So what they determined was the most important, maybe you can guess, it's that fourth one. They put that as priority 1. That's something they want to get their arms around. Number 2 is review the alarm definitions, and then review the monitor definitions, and then finally implement rule management and standardized definitions. So everything that I've shown you is presented and given to the customer that they can work from. Okay, that was DB2. Let's take a look at what an AMIOPS for console management health check portion would consist of. Just like before, these templates, they're going to look familiar. It starts off with console management, features, benefits, and findings. So, for instance, some of the features are, the planned IPL automation. Okay, so the benefit of that increases the availability by reducing mainframe IPL time. Our findings, they've implemented it. They've done a great job, and the end users have control and vision of the entire IPL process. And, this list goes on and on, integration with ER, automation rules. You see a lot of green lights here. That's good. Green dots, I should say. We go to the second page of this, and we've got some yellow here. So these are things we might want to look at a little more closely. Under a feature, enhanced encryption and auditing, you want end-to-end TLS encryption, okay? And you can also audit user interactions. What we found is it was somewhat limited. Some of the newly incorporated sessions did not have encryption turned on. I think it was just an oversight. Also, more encryption can be enabled between the OSA ICC card and the AMI console management servers. So again, that's something that we just want to point out and say, hey, this is probably something you would want to take care of. Another yellow light, something that might need attention, is the browser-based HTML5 user interface. Remember, when we went from main view to AMIOPS, we picked up HTML5, and it's fantastic. The benefit of this is the elimination of client software and keeping up with the latest version of Java. This is something that was really an irritant for them because they had to make sure of all their user workstations, they had the proper level of Java. Okay, so going to HTML5 would take care of that, and we found that they're not quite there yet. Okay, so like with DB2 earlier, there are a lot of metrics concerning the console management implementation. Let's go through these. Big environment, 178 master consoles are run through console management, 4 HMCs, 29 consolidated viewers. So that's 29, views, merged views of consoles and/or HMCs. They have 89 rules, 74 are in use. On the face of it, it's hard to make any judgment about that, really. Often you'll create rules and they just kind of fall out of favor and you stop using them. Something we would just point out, though. They are escalating the important messages, and they're automating a certain number of console and HMC commands, okay? HTML5 is used in some cases. Important messages are being captured in the priority area, and we've got that automated IPL. So on the right, you can see the benefits of those things we just talked about. As far as the recommendations and benefits, one thing I want to break out here. Okay, we talked about making sure that they have the encryption throughout. Another is what we found is when you're configuring console management, you ask for a range of ports to be open in the firewall because often we're spanning networks. So you need to open ports in a firewall. Turns out they don't use a certain subset of these ports. They may as well just turn those back over to security, okay? And as far as rules goes, we have a new feature. Instead of writing an RDL2, which is our proprietary rules, you can take these actions in forms. So the benefit of using forms is that for some people who don't have a programming background, it's deemed as more readable. So let's move to the final slide of console management. And again, really solid configuration. Our customers do a great job. There can be a lot of anomalies and misconfiguration with console management, with all those sessions and IPs and ports, LU names, rules. We didn't find anything wrong along those lines. Everything was perfect. Really, really impressive. So here's our final recommendation, and it's a short list. Again, I talked about we think that they should use the full encryption capabilities. They can return those unused port range to security, and then moving forms or moving rules to forms. Okay, so they deemed the encryption as the highest priority, and that's understandable. They want to return a second. They want to return that unused port range to security, and then honestly, they really weren't that interested in moving rules to forms. You can see here that the effort level is high on this third one here, right? In fact, we could change this number to 487 because the truth is they will probably never do this. And that's fine. You know, these are just recommendations. The way they look at it is the RDL2 rules work great. The folks that are adminning the product are quite happy using those rules. And so they probably will not be moving to forms anytime soon. So that concludes the use cases. I hope you've seen that a health check thoroughly examines your AMIOPS implementation, and it provides a way to improve how you are proactively monitoring your Z subsystems. It's pretty painless as far as the amount of effort that's required of you, the customer. And it's free. You're entitled to it. It's easy to schedule a health check. Just contact your software consultant or your TAM or even your account manager, and we can get you started. So that's it for this month's Coffee Talk. Join us in, I think we're taking April off. I think our next Coffee Talk is May 11th. And we'll look forward to seeing you then. Thank you for your time, and bye-bye for now.